So take a look at the chart, take a look at the question, and we'll give you about 10 to 12 minutes to work on it, and then we will reconvene and talk about it. Any questions on what we're doing? All right, give it about 10 to 12 minutes and do the best you can with it. So, first thing it asks us to do is to find f double prime evaluated at the sine of 2. So we know that f double prime evaluated at the sine of 2 should be the derivative of x cosine e to the x evaluated at x equals the sine of 2. Right? And so if you were doing this problem on the AP test, you'd want to write that out, and then you'd want to just let your calculator evaluate that value. And I had my graphing calculator up here, but then I don't know what happened to it, so I got to reopen that. What'd you guys get for that value?
I got negative 2.173.
Does that sound accurate to everybody else?
Yeah.
I must have typed it in wrong then.
Well,
I got negative 1.520.
Let's plug it in here and just make sure. So option 8 on there, derivative with respect to x, and what was our function? It was x cosine e to the x, right?
Yes.
So x cosine of e, that's natural log, not e, x cosine e to the x.
Right. Let me repeat that.
And we're going to evaluate it at the sine of 2. So if you got something other than negative 2.173, you either typed it in wrong, or perhaps you might be in degrees and not radians on your calculator. So make sure you're in make sure you're in radians, not in degrees. So negative 2.173 should be our answer. Everybody good with that?
Yeah.
All right. So for part B, we're going to try to find h prime of 1.5. So we're going to take the derivative of h, and so we're looking for the derivative of g of f of 2x. And so we can rewrite g of f of 2x as g of u, with u equal to f of 2x if we wanted to, which gives us a composition of two functions. So the derivative of g of u will be g prime of u, so g prime of f of 2x, times the derivative of f of 2x. And so if we wanted to write this as u equals f of v with v equal to 2x, we could. The derivative of f of v should be f prime of v, or f prime of 2x, and then all times 2. Everybody good that that's the derivative of h?
Yeah.
All right, perfect. So then we'll just need to plug in our value. Our value was at 1.5, so we're going to evaluate this at x equals 1.5. So that should be g prime of f of 3 times f prime of 3, and all of that times 2. And f of 3 is given to us. F of 3 is equal to 2. So this is 2 times g prime of 2 times 3 cosine of e cubed, if we plug in for f prime of 3. And g prime of 2 we can find as negative 3. So we end up with this equals negative 18 cosine of e cubed. And what did that come out to be?
Negative 5.915.
-5.195. Everybody agree with that?
915.
Sorry, 915. -5.9.
Yeah, I got that as well.
Perfect. Cool. Any issues with part B there?
Wait, why is it -18 cosine e cubed?
So we had a 2. We had our g prime of 2, which was -3. So that's 2 times -3 gives us -6 times the 3 there.
Oh, you just took the 3 from there. Oh, okay.
Yeah.
Got it.
Yep. Everyone good?
Yeah.
All right. So for part C, we're looking for the line tangent to g inverse at x equals -2. So if g inverse has a point where x is -2, what does that tell us about g? It should have a point where the y value is -2. So we want to know, when does g of x equal -2? And the answer to that can be found from our chart. G of x equals -2 at x equals 3. Everybody good with that?
Yeah.
Yep.
Okay. So once again, we're implementing the inverse rule here, and g inverse prime at -2 should be equal to 1 over g prime at 3. And so g prime of 3, according to our chart, should be what? G prime at 3 should be -4.
Yeah.
So we end up with a slope equal to -1 over 4 for g inverse. Everybody good with that?
Yeah.
Okay, and then it asks us to actually write the equation of the line. So the equation of the line should be using this slope and then the point from g inverse. So y minus 3 equals -1/4 times x minus -2 or x plus 2. Good or no?
Yeah.
Yep.
All right, last part of this one. So we've got the point 3,1 is on this curve, f of x squared plus g of x equals xy minus 1. And we want to find dy dx at that point. So we will need to take a derivative implicitly. So we have f of x squared, what was it, plus g of x equals xy minus 1, I believe. Is that right?
Yeah.
Okay, so what's the derivative of f of x squared? That's u equals, that's u squared with u equal to f of x, right? So the derivative of u squared should be 2u, or 2f of x, times the derivative of f, which should be f prime of x, and then plus g prime of x, and then xy is x dy dx plus y using the product rule, and then the minus 1 goes away and is 0. So we end up with 2 f of x, f prime of x, plus g prime of x minus y, all divided by x equals dy dx. Everybody good with that?
Yep.
Yeah.
All right, and then you got to plug in your point that is given to you, which I believe was what, 3,1?
Yeah.
All right, so if x is 3, this is 2 f of 3, f prime of 3, plus g prime of 3 minus 1 all over 3. And f of 3 was given to us originally in the problem. That's equal to 2. So this is 2 times 2 times f prime of 3. And f prime was this. This is 3 cosine of e cubed. So times 3 cosine e cubed plus g prime of 3 And g prime of 3, once again, from our chart was -4. So plus -4 minus 1 all over 3. And what did you get when you evaluated all that out?
Negative 0.352.
Negative
0.352. Everybody agree with that?
I
Yes.
got 0.314.
Uh-oh. Did a lot of people get negative 0.352?
Yeah, I got it.
All right, so let's just real quick, I'll plug it in here just to make sure. But that should be 12 cosine e cubed minus 5, all divided by 3. So let's just make sure we got 12 cosine of e cubed, and then minus 5, and divided by 3. Negative 0.352. Yep. So if you didn't get that, negative 0.352, but you had this, just check your calculator work. Any questions or issues with that entire problem? It's almost identical to the one we did yesterday, except with different numbers. So it should have been pretty straightforward, I hope.
So when you first checked in with us, should we have been done with the problem if this was like the AP test?
No. That was only after like 7 or 8 minutes. And so for each free response question, this is one full question, you'd get an average of 15 minutes. So,
Got it.
yeah, so you'd be good. I mean, this one was an easier one overall. There's not a lot of like, I mean, there's a little bit of time consuming stuff, but nothing conceptually super difficult. I would guess you should be able to, by the time the AP test rolls around, do this problem in 10 to 12 minutes. That'd be my hope. So that for the ones that are a little more difficult, you got a little extra time.
How long did it take us? 15?
I gave you guys a full 15, I think, before I started talking about it, yeah.
Okay.
All right, let's take a look at this next one. So this is different than what we saw yesterday for sure. This one's got to do with asymptotes and continuity and the definition of continuity and types of discontinuities. So I'll give you guys, I don't know, about 10 minutes here to work on this one, and then I'll check in with you. Sound good?
Yeah.
All right. Get to it. First thing we're asked is what values of k, if any, is f continuous at x equals -3? So we're talking about continuity at a specific point. And so we have to think back to the definition of continuity that I gave you guys. So what's the definition of continuity that we had from a couple weeks ago? It's 3 pieces to it, right?
Just no breaks. The jumps.
Okay, right, there's no breaks or jumps at this point, but there's 3 specific things that we can look at to show us this. One of them is f of -3 defined? The second is, does the limit as x approaches -3 of f of x exist? And the third is, are they equal? You guys remember that? Those are the 3 pieces of continuity at a point. The function
all
has
three
to,
of them have to be like you have to satisfy all 3 requirements in order for it to be true or like continuous. Is that what you're saying?
correct. And
Okay.
and when it says justify, they are looking specifically, if they talk about justifying continuity at a point, they are specifically looking for you to show that all 3 of those things are true. So first off, is f of -3 defined? So f of -3 should be used on which piece? The top, the middle, or the bottom?
The middle.
The middle, right? Because that's when x is greater than or equal to -3. So f of -3 should be -3k plus a half. So that exists, true? K is just a constant. No matter what that constant is, I'm going to get a number here for f of negative 3. So f of negative 3 exists. That one's done. Oh, that's not the one I just, f of negative 3 is defined or exists. That's the one we've done. What about the limit as x approaches negative 3? How are we going to determine if that exists?
Plug in negative 3.
So we have a break here at negative 3, where on
Listed on the
one
other
side,
side.
yeah, so with one side of it, we've got this function approaching as x approaches negative 3. And on the other side, we've got this function as x approaches negative 3. So to see if the limit exists, the limit from the left has to equal the limit from the right. Everybody see that?
Yeah.
So we're
Yeah.
going to see if the limit as x approaches negative 3 from the left of f of x is equal to the limit as x approaches negative 3 from the right of f of x. And if those two things are true, then we can make this limit exist, right? So as we come from the left-hand side, what's the limit as x approaches negative 3? If you plug in negative 3 to this,
0
Looks
over
like-
0.
looks like you get 0 over 0. So now we've got a couple of different ways to deal with this. One is we can factor, right, and solve. Or the other is, what rule can we now use?
L'Hopital.
Right, we can use L'Hopital's rule. So we're gonna say that using L'Hopital's rule, and you'd write that all the way out, that this becomes the limit as x approaches negative 3 from the left of 4x plus 5. That'd be the derivative of 2x squared plus 5x minus 3 over 2x plus 4. Everybody good with that? And as we
Yeah.
approach negative 3 from the right, we're going to use this middle one, and that's just going to be our negative 3k plus a half. And what is the limit here? If I plug in negative 3 to this, what do I get? I get negative 12 plus 5, which is negative 7, right? Divided by negative 6 plus 4, which is negative 2, where I get 7 halves equals negative 3k plus a half. So we can find the value of k that will make this limit exist. And what value of k is that? 7 halves equals negative 3k plus a half. If we subtract the half, that's going to give us 6 halves over 3 equals negative 3k, or k equals negative 1. So if k equals negative 1, f of negative 3 is defined. The limits from the left and the right are the same, so it exists. And if k is negative 1, well, when we plug negative 1 into this, what do we get? We get 6 plus a half, which is 7 halves, which is what it should have been. They are also equal. Good or no?
Yep.
All right. Any questions on part A?
So for part A, our answer would be k equals -1.
Correct. It'd be k equals negative 1, and then your justification is literally all of this work. All right. For part B, we want to know what type of discontinuity does f have at x equals 0. So first off, let's go in here, and at 0, from one side, it's kx plus a half. And from the other side, it is, what is it, 2 to the x over 3 to the x minus 1 or something like that. Yeah, 3 to the x minus 1. And so this one is or equal to 0 for the kx plus a half, and then greater than 0 for the other part. So to figure out what type of discontinuity we have, we should probably plug in 0 for x for each of them and look at those limits, right? So if we're looking at the limit as x approaches 0 from the left, that'd be this one. What does that give us? It gives us a half. And over here, the limit as x approaches 0 from the right of f of x, what do we get if we plug in 0 to this? 2 to the 0 over 3 to the 0 minus 1. And what does that give us?
1 over
1 over
0.
Divide by 0.
It's 1 divided by 0, right? Which is undefined. So this limit doesn't exist. It's going towards what? It's going towards an infinity value. True?
Yeah.
So what is that going to tell us? We've got, on one side, we've got it going towards infinity as we approach 0, and then the other side, we're just hitting a point there and stopping. So what do we have?
Is it a jump discontinuity or no?
It's
Asymptote.
not exactly a jump discontinuity, because a jump discontinuity is where, well, I mean, okay, so a jump discontinuity looks like this, right? Boom, and then here, right? But what we're looking at is something that's more like this, I guess that's 0, right? Here, but then approaching infinity there. And so we could say that that's an infinite discontinuity there. Good or no? Because we're approaching that asymptote.
How did you determine that it was approaching infinity? Did you just do that real quick in your head, or?
Well, I mean, it's 1 over something very, very close to 0, right? If I, put in,
Yeah.
it's very close to 0. So 1 divided by a very small number is a very large number.
It's just called an infinite discontinuity.
Yep. An infinite discontinuity. There's 3 types. There's infinite, jump, and removable. And this one is infinite, because this is what we got going on here. We're going towards an asymptote. All right. Part C asks us to find all horizontal asymptotes for this graph. So horizontal asymptotes, how do we find those?
Limits infinity. Negative.
Limit to infinity and a limit to negative infinity, right? So if we're going to positive infinity, we're going to use the 2 to the x over 3 to the x minus 1. So this should be the limit as x approaches infinity of 2 to the x over 3 to the x minus 1. And if we're going towards negative infinity, then it should be this 2x squared plus 5x minus 3 over x squared plus 4x plus 3. So 2x squared plus 4x plus 3, I think, over, no, plus 5x minus 3. X squared plus 4x plus 3. All right, so what about the one towards infinity? If I plug in infinity to both of these, what do I get?
Infinity
The larger
over infinity.
denominator.
Yeah, I get it. Yeah, I get infinity. I get infinity over infinity, right? Get infinity over infinity. What about that minus 1? Though? That minus 1 is pretty insignificant, isn't it? As x goes towards infinity, 3 to the x is just so much more than minus 1 that minus 1 is not going to matter anymore.
Yeah.
So we could really just worry about 2 to the x over 3 to the x, or the limit as x approaches infinity of 2/3 to the x power. And what happens if I raise a fraction to a power? A fraction that's between 0 and 1.
it'll decrease.
It gets smaller, right? 2/3 squared is 4/9, and 4/9 is less than 2/3. I cube 2/3 and get, 8/27, that's even less, right? So as x goes towards infinity, as this gets larger and larger, this fraction gets smaller and smaller. So what would it be approaching?
0.
0. So to the right, we have y equals 0. And then what about to the left? Well, this one, we know how to deal with this one, right? We could divide by the x squared, but what's another way we could deal with this? The numerator is infinity and the denominator is infinity, isn't it?
Yeah.
So we could use L'Hopital's rule on that, couldn't we? If we didn't want to do all that division and get 4x plus 5 over 2x plus 4, which would still be infinity or negative infinity over a negative infinity. So when we use L'Hopital's rule again, we'd end up with the limit as x approaches negative infinity of 4 over 2. And what's the limit of a constant? It's just the constant.
Would
So
the
we do-
AP, sorry, yeah.
I was just gonna say we'd have y equals 2 to the left. What were you gonna say?
Would the AP test accept, like, if we just knew that the asymptote was 2 because all the other terms go to 0? Or,
No, they want you to show some work. Show the work that leads to your answer. So yeah, you gotta do something. You could
Okay.
factor out an x squared and cancel them and have 2 plus 5 over x minus 3 over x squared, etc. Or you could divide everything by x squared, or you could use L'Hopital's rule. Any of those are fine, but you can't just use the rule. They're always going to want a justification for it.
okay, thank you.
Yep. All right. Those took a lot of time. So I had 2 more that I was hoping to do today. We'll put up this one, or want to do this one? What do you guys want to do? This one? The one with the graph? Or this one?
Easier one.
Sure.
Whichever one's easier.
Whichever one's easier. All right, let's do this one. I think this one will be easier. I don't know if we'll have time to go through it today completely, but we'll see. See if you can get through this as quick as you can. I'll give you guys about 5, 6, 7 minutes, and then I'll check in. All right, so for the first one, to approximate g prime of 5, the best approximation for g prime of 5 should come from an average rate of change surrounding 5. So that ought to be g of 6 minus g of 4 over 6 minus 4. Right, we'll use the average rate of change to approximate the instantaneous rate of change. So g of 6 was 2 minus g of 4, which was 5 over 2, giving us negative 3/2. Everybody good with that?
Yeah.
Any questions on that? All right. For part B, we want to find r prime of 2, where r is f minus g. So what's r prime equal to? R prime should be f prime minus g prime. Right? So we need to find the derivative of f. Right? So the derivative of f, that should be a product rule problem. So that should be x times the derivative of sine of this, which should be, using the chain rule, cosine of that, times the derivative of the root 3x squared plus 5, which should be 1 over 2 root 3x squared, 3x squared plus 5, times the derivative of the 3x squared plus 5, which is 6x, and then plus the sine of root 3x squared plus 5.
I have a question.
Yeah.
For the part A, why don't you use the G prime values in the table?
Because it's asking us to find an instantaneous rate of change, and so we can approximate that using, the best approximation for that is using an average rate of change. And so the average rate of change of G comes from G of 6 minus G of 4 over 6 minus 4, not G prime of 6, because that would be the instantaneous rate of change at 6 and the instantaneous rate of change at 4.
Oh, okay.
Yeah, so we use the slope between the points, the average rate of change, to approximate the instantaneous rate of change. Okay, and so then we plug in 2 to this, and you'd evaluate all this out. This problem likely, I must have not looked at it, but this was probably a calculator problem because all this derivative stuff is just a pain to evaluate. So they would have let you use your calculator to find that. So you would have ended up with, if we plug in 2, well, you'd have 2 times 12, so you'd have 24 times the cosine of 17 over 2 root 17 plus the sine of root 17. Oh, sorry, this is cosine of root 17 times the sine of root 17 minus G prime of 2, which was 4. So you just go through and evaluate that all out and get your answer for part B. Everyone good with that?
Yeah.
I think we're actually already over time here, so we'll stop. We'll do C and D tomorrow. We'll do this other one tomorrow, maybe one more problem tomorrow, and then that should be good for this week. Any questions on anything?
We still have the quiz tomorrow, though, right?
Oh yeah, we're still gonna have the quiz tomorrow.
Is stuff like this gonna be on it or no?
No, it's just gonna be stuff we haven't been quizzed on, like the implicit stuff and L'Hopital's rule and a few more derivatives.